Hello, my name is Brian Mesmer. I'm an assistant professor here at the University of Alabama in Huntsville in the Department of Industrial and Systems Engineering and Engineering Management. I'm also the head of the Imagines Lab, where my students and I are imagining engineering systems for the future. In this video, I'll be talking about two current research projects funded by the National Science Foundation. Both are collaborative work, and I'll be talking about each of the co-Is and PIs on the projects as well. The first project I'd like to speak to you about is entitled Collaborative Research, Organizational and Uncertainty Impacts of Couplings in a System Design Framework. This collaborative work includes myself, Dr. Ali Abbas at the University of Southern California Price School of Public Policy, and Dr. Christina Blobbaum at Iowa State University in the Aerospace Engineering Department. In this work, we are exploring the impact of organizational and physics-based couplings on decision-making in large-scale, complex engineer design problems. Decision-making occurs throughout the design process, from concept decisions at the top of the organization down to the nuts and bolts decisions at the lower levels. The couplings tie together both the organization and physical components of a system. In this work, a satellite system model was formed with multiple levels of components. We also developed a value model for the satellite system that captures the desires of a commercial company, in this case in the form of a net present profit. We then examined the changes in value with respect to changes in attributes and design variables, and found that it was critical to capture the global sensitivity of the value to design variables, and not just the local sensitivities. We also developed visualization techniques to relate the value-driven design methods of scorecards to the strengths of the couplings in a system. We've also explored the impact of requirements on system value. As system engineers, we know that requirements constrain the design space, disabling us from exploring many of the design alternatives. In this work, we are showing the impact of those requirements on the value quantification of a system. A value-based system engineering framework has been developed to enable the use of value functions in the system design process, enabling consistent decisions throughout the organization. The next steps will be the incorporation of uncertainty into the value-based systems engineering framework. The next project I'd like to speak to you about is entitled Collaborative Research, Visual Analytics for Creation of Value Functions in Complex Systems Designed Under Uncertainty. The collaborative team includes myself, Dr. Timothy Simpson and Dr. Michael Yukish at the Pennsylvania State University, and Dr. Christina Blobbaum and Dr. Elliot Weiner at Iowa State University. In this work, we are exploring the use of visual analytics to create and validate value functions to support the design of complex systems under uncertainty. A primary question of this research is how can we know with an acceptable degree of confidence that a proposed value function will rank order alternatives in the way that the stakeholder would rank order them himself. In this research, we have taken the satellite system from the previous project and have used visual techniques to explore the design space, examining the impact of uncertainty on attributes and value. A key observation was the quick identification of attributes that were highly sensitive to changes in design variables. In order to handle uncertainty in a mathematically sound manner, we use utility functions to capture not only value preferences, but risk preferences of the decision maker. Through these utility functions, we showed numerically the impact of risk preferences on rank ordering of alternatives. We are currently reviewing rank order metrics and, combined with coupling strengths, are striving to identify a process of determining which attributes should be included in a value function to achieve a desired fidelity. The research that I have just introduced is just a small part of all the research that's being conducted in all the labs that are working on this collaborative research. We are more than happy to discuss our research with you further, and please contact us if you have any questions.